There it is.
One security guard. Let's go get him.
No, wait. We have to be smart about this. I'm a robber.
We need a password.
Oh, I know. Let's do some math.
To find the component form of the vector, you're going to subtract your initial point from your terminal point. So you'll start off with your 1 minus a negative 6, and then you'll go over to your negative 1 minus 4, and then you'll do your 3 minus your negative 2. When you simplify that down, you'll get the component form of the vector, which is 7, negative 5, 5. So our password is 7, negative 5, 5.
So, how much dynamite do we have to use?
I don't know. Let me try my key first. Well, let's do some math to find out how much we need. So to find how much dynamite we need to use, we have to find the dot product of these two. So it's really simple. You just take each point and you take the coordinates, negative 4, oops, and then you times it by 1, and that gets you negative 4. And then you're going to add that point to whatever you get on your second set. It'll be 1 times 3, which gets you 3. And then third set, 4 times 1, and that gets you 4. And when you add all these together, your 4's cancel out, which leaves you with 3. So we need 3 dynamite. Alright, so we're also going to need to know how to find the cross product later whenever we're doing orthogonal directions. So to find the cross product, it's also really easy. You just notify the points I, j, k, and that's I, j, k as well. And then you go and you kind of make like a graph almost. And you're going to take each point and take your i's, it's negative 4, and my next one's a 1. Then you take your j's, 1, 3, 4, 1, those are your k's. And then to find it, you're just going to pretty much do like an imaginary line saying that you don't care about those numbers. And then you're going to take these, you're going to take this number and multiply it to that number, so that's obviously 1, plus whatever this number times that number is. So it's going to be plus 12. Alright, so that's your first set of points. And then you're going to do the same thing. You're going to draw a line through this one, and then you're going to want this number right here, this set. So you're going to take 1 and multiply it by this negative 4 over here. So then you get negative 4, and then take the same thing. You're going to get this 1 and multiply that to this 4 over here. And that's positive 4. That's going to be your next set. And then I know it's confusing with the lines, but you're going to do the same thing here. And now you're going to look at these points. So this 3 you're going to take to this negative 4. That gets you negative 12. And then you're going to take this point. 1 times 1 is 1. So you have positive 1. And there's your 3 points. Now let's simplify it down. That's 13. This is 0. 4's cancel each other out. And then that's negative 11. And then that's going to be our cross product. And then just to get everything back in the correct form, you're just going to go back to IJK like we did up here. So it's going to be 13 I plus 0j, and then minus 11k. Alright, so lastly, just to find where we need to place our TNT and how much of it, just to verify everything, we're going to have to find an orthogonal set of equations. So we're just going to test this to see if it's parallel, orthogonal, or neither, and if it's orthogonal, then great, but if not, then we have to keep looking. So the easiest way to visualize this is you look at your two equations. You have u and v, so those are your vectors, and then you're going to go, and it's easiest to just ignore any of the signs and pretend that they're all positive. So we're going to go through and just make all these positive, make life easier. So this will be 12, and then we're going to go ahead and we're going to put all of our u values in the numerator and all of our v values in the denominator, just to see if this is a scalar multiple, because the rule is if something is a scalar multiple, then it's parallel, which we don't want. So then we'll throw 8 on the bottom, go to our next set, 6 on top, right there, 4 goes there, and then 15 right there over 10. And then to determine if it's a scalar multiple, all you have to do is pretty much simplify this. So 12 over 8 reduces down to 3/2. 6 over 4 reduces to 3/2. And 15 over 10 reduces to 3/2. And the fact that all of these are pretty much the same numerator, or u ratio to v ratio, it's parallel. So we have to keep looking for another equation to determine how much dynamite we need. Okay, so we're going to try this just one last time to try and get an orthogonal equation here. So first off, to tell if something is orthogonal, the dot product is going to equal 0. So we'll start off, we'll just go ahead and take the dot product of this. We'll start here, 0 times 4, that's our first set. Second set is -3 times -2. And then our third set will be -2 times 3. And then when you simplify that down, 0 times 4, anything times 0 is 0. And then -3 times a -2, that equals +6. So we're going to have the 0, the 6, and then our last set is -2 times 3 is a -6. And then whenever you add these together, 0, you can forget that. That 6 and -6 cancel out equals 0, which means that this is orthogonal. There we go.
I got the dough. Let's go. Give it here.
If you ain't talking money, I don't wanna talk.
I'll call you back.
You can tell I got this sack just by the way I walk.